Okay. Term number one. What's a ratio? A blank is to blank. Give me an example.
Like a ratio, like let's say like 1 is corresponding to 1 almost.
1 to 1
Yeah.
is a ratio, yes. Okay, can you give me another example?
2 to 4.
2 to 4. Okay, so you're just going to keep giving me numerical examples. Can you give me a non-numerical example?
Triangle to triangle.
Okay, anything else? Anybody else? Examples of...
Can I give a definition?
But you don't want to give me an example.
No.
All right, go ahead.
It's a relationship between two things.
What 2 things would you like?
2 gazelles and 2 lions.
Okay, good. Anything else?
Or Batmans and 2 jokers.
Nice. I like I threw more Batmans in there. Batmans to jokers, gazelles to lions. What'd you say? 1 to 1 and triangles to triangles. And what was your definition, though, David?
Relationship between 2 things.
Is that good? So we're comparing a relationship between Batmans and jokers, gazelles and lions, 1 and 1, triangles and triangles. Okay? Relationship between 2 things. Okay? Batman's 2 jokers. 1 to 1. By the way, is that the only way we can express a ratio? Here.
You can also do with is it a colon?
A colon, good. 1 to 1. Any other ways? The one we're never going to use, you could use the words 1 to 1. We're going to use fractions. Now, when your fraction is numerical, when you're comparing the number of girls to the number of boys in the classroom, that should be a simplified ratio. Okay, so don't tell me it's 10 to 5. Tell me it's 2 to 1. Okay, so always simplify your ratios. Questions here? Outstanding, strong start. Second half of the board, however, things get a little bit more interesting. What's a proportion? Go, Scott.
A ratio based on the data of another one?
It's not horrible. Can you delve a little bit more deeper into that? No?
I don't know.
Anybody else? So, Ani, what do you think? Can you give me an example of a proportion or something that's proportional?
Like a fraction or something.
Well, isn't a fraction just a ratio? When does the ratio become a proportion?
Like when it's like that, like certain
Abby, do you have an idea, or are you just doing some yoga back there?
Like both things are equal, like they're proportional. They're like equal to each other.
Okay, but what are those things?
The negatives.
You're getting warm. Yeah, I mean, you're right there. So if I say 2 equals 2, is that a proportion?
Yes. No.
No, it's just an equation. So what makes, and Abby's in the right track there, it does involve an equal sign. We need an equal sign. Notice the ratio didn't involve equal sign. But what makes an equation become a proportion? Go ahead.
The relation, the relation of two ratios.
Perfect. Okay. Take this definition for ratios and change the word things into ratios. Okay. Let me get this out of the way. Relationship between two ratios. Okay. For example, if 2 Taylor Swift tickets cost $90, how much do 100 Taylor Swift tickets cost? Go ahead, solve that. Don't be... Yes?
4,500.
Good. How'd you do that?
I did 2 divided by 90 and then multiplied it to 100.
Okay, and that can get confusing depending on where the variable is, so I would suggest using this technique. What's that technique called? Cross multiplying. Now, I set up that proportion for you. Is that the only way that I could set up the proportion? And the answer is no. I did tickets to cost equals tickets to cost. I could have done tickets to tickets equals cost to cost. When you're setting up proportions, the top numbers have to compare to each other, and the vertical numbers have to compare to each other. In other words, if I go back to this proportion, the 2 and the 100 are the number of tickets. The 90 and the X are the cost. I could have also done 2 is to 100 as 90 is to X. Okay, where the 2 and the 90 are tickets and cost, the 100 and the X are tickets and cost. Now, the way Sia describes solving that ratio, or proportion, is not incorrect. However, as they get more complicated, it can get a little bit confusing. This, I think, is cross-multiplying. It eliminates all that confusion thing. Am I dividing by 100? Am I multiplying by 100? Here you just cross-multiply and go. Okay? Problems? You've seen this before, right? Please tell me yes.
Yeah.
Excellent. Then I'm just going to move on. Okay, now we're going to actually do something more traditional geometry-wise. What's a triangle?
It's a figure with, it's a 2-dimensional figure with 2 sides, and 3 sides and 3 angles.
3 sides and 3 angles. You need both of those?
And we need 3 sides.
But you don't need 3 angles?
No, we need both.
You need both.
Yeah.
Yes or no? Do you need both sides and angles? Maybe. Good, safe answer. Yes or no?
Well, the 3 lines have to connect at 3 vertices, so that's gonna make 3 angles.
Oh, so now you're adding another element. It's not just 3 sides. You want more than 3 sides?
No, the 3 sides.
3 sides? No, I didn't mean you want like 4 sides. I meant you want 3 sides, but you want more to your definition than just 3 sides.
Well, I thought she said lines.
Okay, well they shouldn't be. Okay, that's the next thing. They shouldn't be lines. They're line segments. Okay, so 3 line segments, and then you added. What did you add to it?
That they have to line at 3 different vertices.
Vertices. Good. You can't just have 3 sides. Right, because this is not a triangle. But that is 3 sides, yes? Is it 3 angles? No, only 2 angles. So do we need the 3 angles? there's a couple different ways we can approach it. We can take what Kushi said and use the fact that it has 3 sides and 3 angles, or we could take just the 3 sides and say what Rebecca said about them meeting at the vertices and having 3 vertices. I don't care which one you want to use. What do you prefer? Bella, what do you prefer? Kushi's definition or Rebecca's? Is that what you said, Rebecca? Is that good?
Yeah.
Okay. Beautiful. We're going to start today, not start today, we're going to continue today talking about triangles by looking at different types of triangles. Evan, you know any different types of triangles? There are 6 possibilities, by the way. Do you remember any of them?
Acute triangle.
Oh, beautiful. What's an acute triangle?
It's a small one.
Could be.
All the
It's
angles
small and cute. It's got cute little hints and
It's a
decorations.
cute
No,
triangle.
no.
with the angles,
What about the angles?
they're all on 90 degrees.
Love it. You got any others? That's one.
I'm guessing that there would be an obtuse one.
Oh, there would be an obtuse triangle. Do you know what an obtuse triangle is?
It's like when the angles are over 90. One angle.
1 angle over 90, because if you got more than 1 angle over 90, you have a train wreck.
Yeah.
Okay, good. That's 2. You got any more?
No.
You got any more?
Oh, a right triangle.
Good. A right. That's my right arm. Get the right triangle. Good. That's 3. You got 3 more?
I don't think so.
Okay. Lucy?
Oh, I know.
You had right triangle. See ya.
Equilateral.
Equilateral. What does that mean?
All
Look
the,
at you using the big words.
all the sides are equal.
Equa, meaning?
Equal.
Equal. Lateral, meaning?
Lateral. Long.
Do you not know what lateral means?
I don't know.
In football, a lateral, what do you do in football? You throw it to the
Direction.
side. You throw it to the side. 3 sides. Good. There's 2 more. Rosemary.
Scalene and isosceles.
Scalene, meaning?
I don't know.
What'd you Google it?
Yes.
Yeah, great. For a second, you were kind of impressed with Rosemary's knowledge, and then you realized.
Well, actually, I knew both those words too, but I don't know what they mean. either.
Yes.
Yeah, but you didn't Google them.
No.
Okay.
Isn't
Yo.
isosceles what it's 2 equal sides?
Wait, that's a new word. Hold on.
Isosceles.
Did you say isosceles?
Yeah, you do.
Oh, she said isosceles. Okay, what's isosceles?
What isosceles?
Isosceles.
What is 2 equal sides?
Isosceles. Isosceles.
That.
Isosceles.
Yeah, that. Isn't it what is only 2 equal sides?
Correct.
Okay.
I should probably write all these down, right? Equilateral, isosceles, scalene. Okay, squiggly mark. Evan, help me out. What were yours?
Acute.
Acute,
Obtuse.
obtuse, and right. Okay. What do these have in common? What is that comparing?
The equal measure.
Beautiful. These are angles. What are these comparing? Did you Google this?
No,
Oh, okay. Go ahead.
the sides.
The sides. Let's go back to this one. So, Scott, you said that means that they have 2 equal sides.
Does scalene mean it has no equal sides?
Yeah, scalene, no equal sides. Equilateral, 3 equal sides. But you said it has only 2 equal sides, right?
Yeah.
So we can this is a decision you have to make. You all, I should say. There's two ways to define isosceles. You could define it as exactly two equal sides, or you could define it as at least two equal sides. Which would you prefer? Have we had the golden retriever dog discussion yet?
Yeah.
We've defined a dog with a golden retriever, but have we talked about dogs and golden retrievers? Okay, so this comes up a lot, and I always use dogs and golden retrievers as my comparison. And it goes something like this. Are all golden retrievers dogs? Yes. Are all dogs golden retrievers? No. Okay, so if we define isosceles as having at least two equal sides, then the isosceles becomes a golden retriever where all isosceles triangles would be triangles. Some isosceles triangles will also be equilateral, but not all isosceles triangles will be equilateral. So I don't care how you want to do it, you just need to decide if we're going to do isosceles as exactly two sides or at least two sides. Which do you prefer? Go. There's no right answer. It's just a decision that you all have to make moving forward, so I know how we're going to handle this. You like exactly?
Yeah.
Exactly?
Yeah.
Everybody good with exactly? Okay, fine. All right, 3, 2, 0. We're going to focus on these two today. Equilateral and isosceles. Okay, so let's draw them. There's your two pictures. You want to do the easier one first or the harder one? Want to get the hard one out of the way?
Yeah.
Okay, let's do that. Let's talk about the isosceles. The isosceles triangles, we have a bunch of terminology. The non-equal side. Anybody remember what that's called? Nope, that's the base. No hypotenuses, they're not right triangles. The equal sides are called the legs. Now, an isosceles triangle does not always need to be sitting on its base. I could take that triangle and tip it over. So the base, by definition, is not the side it's sitting on. It's the side that is not congruent to the other two sides. Okay. These puppies are called base angles. Base angles. And this guy up here is called the vertex angle. Vertex angle. Wow, that looks a mess. Is that okay? You following me on that though? You good? Okay. 6 parts to every triangle. 3 sides, 3 angles. No exceptions. Now notice the way I drew the isosceles triangle is I made those base angles congruent because that's a true statement. Those base angles in an isosceles triangle will always be equal to each other. By the way, what do you know about all 3 angles in a triangle?
When added up they equal 180?
Good. When added up, they equal 180 degrees. Hi. Spaniards are here. The Spaniards are here. Woo! Hola. ¿Cómo estás?
Un profesor de matemáticas.
Sí, sí, sí.
Yeah.
clases? ¿Cálculo y
Geometría.
geometría?
Sí.
The Spanish exchange students.
That's about all I got.
A bunch of them.
Yeah, I got
You guys are gonna make it.
Well, I'm going to mention mathematics, maybe they're gonna want to see. All of them.
The Spaniards are here, everybody. They're from Spain.
I figured.
Barcelona.
Barcelona. Oh. That's where my daughter studied abroad.
Oh, yeah.
Not that anybody
Negocios?
cares.
Business?
Yeah. Yeah, through EDM.
Some friend of the Pitágoras.
How long are you guys here?
Pitágoras, teorema
We
de
arrived today
It's a lot of group work, right? Yeah. Ya, bueno, aún en las clases de matemáticas hemos cambiado un poco este estilo de grupos, trabajando en grupos en vez de individualmente. Yeah. Okay.
Adiós.
Adiós, gracias. La hija del señor estudió en Barcelona, la Universidad de Indiana. Está estudiando negocios. Ya, pasó un semestre. Un semestre en Barcelona.
Administration and direction company.
Have fun. Okay. What?
None of them waved back at me.
Do you want to go see your counselor? Work through this, or are you going to be okay? I guess you'll have to wave it up to somebody else today and see if they'll acknowledge you. Scott, don't encourage it.
Okay.
All right, where were we? Oh, base angles are equal, and the sum of the angles in a triangle, doesn't matter what it looks like, is 180. We're going to talk more about that later, and in fact prove that. But for now, moving forward, we can file that away. Okay, so let's go back to this isosceles triangle and do a little bit more work with it. I am going to take this and split it in half. Okay. That thing is called an altitude. It's off a little bit. Let me fix that. It's bothering me. Okay, there we go. That's called an altitude. Altitude. And it does a bunch of different things. So instead of listing them all, I'm going to show you. It's perpendicular to the base. It splits the base in half. And it splits the vertex angle in half. All of that from that one little red line. It also splits the isosceles triangle into two different types of triangles. What kind of triangles are those? Right triangles. And what applies to all right triangles?
Add up to 90.
Pythagorean theorem.
Oh.
Okay, so we'll be doing some Pythagorean theorem with this. And notice that each of those right triangles, the hypotenuses of those right triangles, are the legs of the original isosceles triangle. Okay? Why else do we care about that altitude? You know how to find the area of a triangle, right? Yeah, what is it? What's the formula?
Base times height times a half.
Beautiful. Area of a triangle is 1/2 base times height. That altitude is also known as the height of the triangle. So we're going to need that when we do some calculations here. How are we doing so far? Okay. We're going to do the same thing with the equilateral triangle, but the equilateral triangle, but it's less exciting. It's actually the same thing over and over again. So it's perpendicular, it cuts the base in half, it cuts the vertex angle in half. It's the same thing that we saw with the isosceles. Okay, we good? Questions so far? Excellent. Let's do an example, shall we?
Sure.
Let's see. Let's draw this. Ooh, it's red. Let's make this 13. We're going to make it isosceles, and we're going to make this leg 20. I would like to know the area. Oh, we'll make these centimeters. Go. By the way, it's not 1/2 13 times 20. Just cutting that off right now. When you get done with your work, check with your group and see if they have the same answer. I don't want multiple answers from one group. Yes, you may have to talk to that stranger next to you or across the table from you. They will not bite you. And if they do, they've had their shots. Right, Abby? You've had your shots, right? No rabies? Good. That's what I like to hear.
Hi, Mr.
Hello, Karen.
How's your morning?
Outstanding. How's yours?
How many cups of coffee today?
None.
Really?
Not a one.
Why?
Kind of monster. Shifted gears a little bit, wasn't in the mood for coffee. Start.
It's a lot easier with two legs.
Yeah, but your 20's in the wrong spot. 20's the leg.
Yeah, that's why it's on the
Okay. You do it.
That's not right. You're not doing this right.
I don't know how to do it then, okay? I'm trying. At least I'm trying.
Shots fired.
You just said that's exactly not what you do. But that's the fine.
Okay, so from most group, keep working, by the way. I'm just going to talk while you're working. It's kind of like whistle while you work.
130 is this whole thing. Yeah, it is.
Most of you did that. That's a good start. Keep going.
No. You multiply them out and then. So what are we doing?
No problem.
What's half of 13?
Oh,
What we got, kids?
it's when we're trying to square or C squared.
Anything? Progress?
And 20 plus 20 equals 400. Subtract 169 over 4 from 400. 1,431 over 4. And then you square with that, so you get 18.9.
Yeah, you do. It's the height of the triangle.
So 400 minus 160.
Wow. You guys are making this much more difficult than it needs to be.
I think we got it, Mr. Reedy.
You think so? All right, hold on. Let me ask you a couple questions. How long is that? 6.5.
Wait, and what's 400 minus?
Right angle.
1,400.
How do you find H? Pythagorean theorem. Keep going.
I got it. Well, I got it.
I don't know. I didn't get a problem. What'd you get? So you just wrote down random numbers.
That's exactly what I said.
Find that.
I'm finding that.
We'll find it. We'll find that. We'll find it. Let's go. God.
Because there's the hypotenuse, the 20.
I got a very ugly number.
Me
Call me.
too.
I told you.
Okay.
Okay.
Well, that's what 6.5 times 6.5.
Yeah, that's squared. Because you're putting it in the Pythagorean theorem.
Yeah, 1 or 2 decimal places.
Squared equals 100.
Yeah, I'll try to tell you quickly. Plug the chart. I don't know. Hold on. I'll tell you in a second. What did you get?
18.9.
Well, that's the height of the triangle. It's not the area.
Oh,
Yeah, it's about. Oh, it's because your 20's in the wrong place. Remember, that's the hypotenuse that's over there. Switch to 6.5 and then 20. Oh, that's good. Now find the area of the triangle. How we doing? Hold on. Yeah, keep going.
I got 16.4.
Yo.
Wait, which triangle do we find the area? Half of it or the whole?
Can I use your calculator?
God.
Yeah.
18.914.
Oh,
57
yeah.
over 40 is 80.
So how do you multiply by a half too many times?
Where do we find the area? Not the triangle.
The red triangle. So take your answer.
God, I'm square rooting it. That's what I did, but it doesn't work because I can't put
Decimal form.
Oh.
Okay, so 8 squared plus 6.5 squared equals 20 squared. Remember, when you're doing Pythagorean theorem, the C term has to be the hypotenuse. Walking around, most of you were able to find that the height of that triangle is 18.9. Yes? And you should store that value. Don't use 18.9 as you continue your calculations. Use the stored value. Now, moving forward, calculating the area of the red triangle, you could do it two ways. You could find the area of the yellow triangle and multiply it by 2, or find the area of the red triangle that we're looking for, which would be 1/2 times the base times the height of 18.9. That gives us, see, what is it? 122.9. We'll go with 9. What are my units here?
Centimeters.
No,
Centimeter squared.
centimeter squared. So, here's what's going to happen. As we start getting into these calculations, the memorizers in the room are going to try to memorize. For the memorizers in the room, you realize that that didn't pan out so well on that last quiz that you took. You have to get away from memorizing if you're going to succeed in this class. Plain and simple. You can't just go home and memorize 1/2 base times height and be able to solve all the problems I'm going to throw at you. Because I'm very seldomly going to give you a problem that gives you the height and the base and ask you to find the area. Okay, because I could have a 4-year-old do that. Well, maybe not 4-year-old, 6-year-old. Let's go with 6. Okay. You're going to have to understand what you're doing. That's going to take a little bit extra work. And as you struggle with that, you can come and see me and I'll help you with that. Okay, but just going home and memorizing 1/2 base times height, memorizing that is not going to get you where you need to be. Okay, you're going to get frustrated quickly. Okay, just like, perfect example here is Pythagorean theorem. So the memorizers in the group have just memorized, a squared plus b squared plus c squared. If you don't understand how it works, then you end up putting the 20 in the wrong spot. And do 20 squared plus 6.5 squared equals the height squared. Doesn't work that way. You need to understand the theorem so you know where to put the values. Okay? Questions? By the way, this is the start of chapter 3. So we're doing some more traditional real geometry. On today's Tuesday. On Thursday, when I see you again, we have a lot of catching up to do. So I will have, we'll spend some time going over the last day of chapter 2, which is the parallel lines with the transversals, because I'm sure you have some questions about that. Then we'll continue on with ratios, proportions, and triangles, and then I've got some more stuff as we get closer. My plan here is to make sure that you have nothing to do over Thanksgiving break. I'm a big fan of breaks being breaks. So when we leave next week, you'll have no geometry to do over the 5-day break. And the same is true with winter break, obviously, because you'll take a final before you leave for winter break. Okay, I know that won't be true in all of your classes. It will be true in this class, however. Okay, questions?
Is the final in unit like everything we've done so far?
Everything in this semester. Question?
When are we gonna get, like, if we do get a final study guide, when are we gonna get it?
In plenty of time to start looking at it, but not early enough where you can be psychotic and do it 74 times before the final exam, like some of you might do. Okay? Beautiful.
Notes?
Done. Let me stop this.